Welcome, ladies and gentlemen, to this episode. Today, we look at the charging and discharging of a capacitor. To begin with, we define the term capacitor. A capacitor is a device that is used for storing charge. It is made of two plates. One plate is normally connected to the negative terminal of the battery, while the other plate to the positive terminal of the battery. Between the plates, we may have a material known as a dielectric, which could be air, could be glass, could be electrolyte, could be paper. The name of the capacitor or the name assigned to a capacitor depends on the material in between. For example, if it is paper, the capacitor will be referred to as paper capacitor. Now, the plate connected to the negative terminal of the cell receives electrons from that terminal, while the plate connected to the positive terminal of the cell or battery loses electrons to the positive terminal of the battery. In the process, that plate that loses electrons acquires a net positive charge. Charges accumulate on the capacitor to a point where now no more charge can accumulate because the capacitor is fully charged. Now, to explain how charging occurs, we have this diagram here where electrons flow from the negative terminal of the battery all the way to a plate that now becomes negatively charged, and at the same time electrons leave the other plate, which then acquires a net positive charge. Now this continues until the voltage across the battery equals the voltage across the capacitor. If graphs were to be drawn, then at that point the voltage would remain constant. Now, discharging of a capacitor is normally done across a load. The load could be a bulb or a resistor. So current flows in a complete circuit from X to Y, or electrons flow from Y to X. So as electrons flow from Y to X, the plates get neutralized because of opposite charges combining. In the process, the capacitor loses charge, and a graph to that effect of voltage against time would show a discharging process. Now, this circuit here shows how charging and discharging can occur within a single system, where if the terminal is connected to the switch is connected to terminal 1, then the battery is actually charging the capacitor. When the terminal is connected to, when the switch is connected to terminal 2, then the battery is no longer in the connection. The capacitor is being discharged across the load R. So discharging graphs can also be drawn for that, for voltage against time. These two graphs here show the charging and discharging of a capacitor, where the voltage increases to a point where it becomes constant, meaning no further charging is possible because the potential difference across the cell now opposes the charge flow from the capacitor, or the other way around. In discharging, the potential difference across the capacitor is lost because it discharges across a load, the load that we named R in this diagram here. Now, the viewers, I will leave you with an assignment to draw graphs of charging and discharging for current against time. Until next time, bye.